Hi, everybody. I hope you're all here for building your first data pipelines. I'm going to be talking about why you should build a pipeline and how you should document it, and mostly demonstrate the use of the tool Luigi, which is what we're going to workshop together as a group. It's a workshop, so it's going to be hands-on. You're going to form groups later on during this session with your table mates. Speak. We can try it. It's apparently, I will try to see if it will work, and if not, I will just speak really loudly and project a little more. Can folks hear me? All right. Channel 1? Yeah, there we go. All right, we have a microphone. That's exciting. So if you are going to be participating in the coding section of this workshop, I'd ask that you try and start to install Luigi and Folium right now. We're also going to rely on pandas and scikit-learn, which should be installed if you're running Anaconda. If you're not, I either recommend you use it, which we sent out before the tutorial, or you can install it using the other methods appropriate to your particular machine. But hopefully we can get to a point where there's at least a couple laptops on each table working. But I will get started with the sort of talk and section of this presentation. So I'm Hunter Owens. I'm a data scientist for the city of Los Angeles. This is building your first data pipelines. So we're going to talk today about why you might need a data pipeline. For me, these are the reasons I use one. One is to organize my own method of work. The second is because I often need to edit and rerun these things. And the third reason is so I can collaborate with other people. Just show of hands in the room, how many people in this room have sort of built sort of scripts that pull data from somewhere, do something to it, and then report it out to some other system? Yeah, so that's a thing we do all the time. It's basically, I suspect if it's your job is like mine, it is a lot of your job, and it's often a hassle, because how many of those scripts broke? Yeah, they broke. They always do. So that's why we need robust data pipelines. We need our plumbing to work and not crash and die at 2 in the morning. Not speaking from experience at all in that case. So there's a lot of tools out there that help you document how your data goes from some external system, a website, an API, what have you, into your own system. So there's Make, which is actually a build system. There's this great blog post by Jeremy Escanas called Using Make as Your Data Pipeline Tool. I'd highly recommend you read it. It's a great blog post. I will link to it in the repo at some point tonight. A lot of people use shell scripts. How many of you use shell scripts to do this process? All right, cool. So a lot of shell scripts. How many of you used like a pure Python script? All right, so about how many of you used Drake? Yeah, a couple. And then anybody know how to use AWS data pipeline? Yeah, it's there. So there's some sort of, why I listed those in those order was because Make, shell scripts, Python scripts, for this audience, a lot of you will have seen these before. It's pretty simple. It's just like a declarative set of steps, essentially. Like step 1, step 2, step 3, done. Drake and AWS are really powerful tools that you can use, especially the AWS Data Pipeline Toolkit. It's got a lot of documentation, JSON configuration, and it's a lot. But I'm here today to talk about Luigi, which was developed at Spotify and is built entirely in Python. And this is not. Can you all? Oh, okay, cool. So that's what we're going to demonstrate using today. But I did want to sort of start this talk by saying there are lots of different tools to do this. And when you're building your data product, you should, or data, you're doing your analysis, you should think about hey, maybe there are definitely times I still just use Python scripts or shell scripts because I don't need to use Luigi, it's overkill. And there's definitely times I've seen the AWS toolkit used more effectively than this. But Luigi is nice for a lot of reasons. One is it's entirely written in Python. I like Python. It is what I use day to day. So not having to learn how to configure AWS and all this obscure JSON all the time, or try to remember how make syntax works. I never remember how make the syntax works. The other thing is it produces a graph of your data dependencies. So what's really nice is it requires you, by writing Luigi tasks and targets, you've essentially defined the relationship between all the different pieces of analysis and stored pieces of data on your system, and therefore it also is really easy to collaborate on, because I can just say, clone the repo and run this, and it will generally work once you have it configured on somebody else's machine, because it's just Python. And then finally, it really has a nice level of scale, which is like, it's both appropriate when you're working on the local file system, and then also appropriate when you're working with like a Spark or Hadoop cluster. And you don't have to necessarily rewrite a ton of stuff if you switch between those two environments. So it's middleweight in terms of the tools. It's not as lightweight as a Make or Shell script. It's also not as heavyweight as some of the sort of big data cloud solutions, but I don't have big data a lot. I work for a city government. So some first principles about how Luigi works. It's kind of at this idea of everything should be an atomic operation on some sort of file type system. So this is my Python little script that I did to do some sort of data analysis. I've got a little code base module, and it's got some functions: generate features, fit the model, and deploy the predictions. How many of you have written something like this in the past? All right, cool. So this happens. I put it in cron put up a cron job. I need to do this every night. For example, one of the things I did at my old job is every month we had a job that helped predict whether lead, what were the odds of lead poisoning at certain different houses within the city of Chicago where I used to live. And we wanted to send off a list of recommendations of which homes should be inspected each month to the city's Department of Public Health. So that was an old task, and this happens. Well, not literally a doesn't define error, but what happens is something breaks, and when you've got expensive operations like fitting a model or loading in a bunch of data into Postgres, or stuff that takes, often an hour or two to run, it's really annoying when you screwed up on the syntax on the third step, and then you've got to rerun an hour worth of code. So you end up doing something like this. Yeah, see, I had this example. You want to start resuming things only at the broken step, which is like, all right, we know steps 1, 2, and 3 ran successfully. Or we know step 1A, 1B, and 1C ran successfully, but 1D did not, and this is like downloading data from a portal or using an API. So the idea of reducing everything to like a single unit of operations on either a file or a database is really useful in terms of like restarting these jobs and also just documenting how this goes about. So we end up writing something like this. So we've still got generate features, fit model, deploy predictions as we had in the past. And then I wrote something, you can write something that says like, if the features CSV doesn't exist, generate the features. If the model has not been pickled, fit the model. And if the predictions date is not today, deploy the predictions. So that's great, but this is ugly. Now imagine if we had 10 different data sources you needed to combine. You needed to fit the model and test and train 2 different models and compare the results. And then you need to deploy them with some sort of weird non-regular schedule of like, it's not today. Like this isn't too ugly, but this gets really ugly and hard to document very fast. So Luigi introduces 2 pieces of abstraction for you to build that without making it look super ugly, which are 2 types of Python objects that they wrote in the package. So one is a task. A task is a unit of work. So it's a piece of analysis. It's a downloading something from an API. It's whatever sort of code you want to run. Then a target is a representation of the saved state of information. So this could be a pickle file, certain rows in a database, a table in the database, local files, Hadoop file system files. There we go, HDFS, right? Yeah. So let's take a look at what they look like. So here is a very, very simple task. So you take, you subclass Luigi.task. I've given it this parameter, which is to say, like, you might have tasks with lots of different parameters. In this case, the default parameter is 42, but we can change it. And then there's this, and then you want to subclass, always, all tasks you want to subclass 3 different methods. The first method is the requires method, and this is some other set of tasks. If it's your first task in the pipeline, you use the external class task. I'll show you that in a bit. But you can see that in order for my task to run, some other task will have had to be run, and whatever target some other task produces needs to already exist. So you'll see we've got run here, which is opens up the file, writes hello world, and then closes the file. And then finally, in our run method, and that's the code that we're going to execute. And then, like how, there we go. Ha! Come on, stay. There we go. Seriously? Stay. All right, so then it returns this local target object, and it's got the name temp foobar bar-s, and that's the parameter, which is going to be, in this case, bar-42.txt. So I'm going to pull this up in a terminal and run it, and hopefully nothing's going to break. Yeah, so that particular example won't work because there is no some other, there's no preceding step, so I'm going to show you an example without a preceding step. Yeah. So let me make this. Can y'all read this? Awesome. So where did I save this? So if we look at example.py, I'll let y'all, this is, you see how it says external task? That's basically just a quick thing to say this is a task that does not require any other task. It exists sort of first. And then we've got a run method. So it just outputs hello world from run, and then it writes it to the temp directory. And it actually handles, if the foo folder doesn't exist, it's going to handle creating that for us, which is really nice. I guess if temp doesn't exist. So let's. So if we, it's gonna be hard to like type and hold the mic. So I'm just gonna try and talk really loudly. If you folks in the back can't hear me, I will figure out a way to make it work. Yeah, they got this is the mic for the recording. So give me one. Let's. Yeah. Yeah. Thanks. Sorry, y'all.
I neglected to volunteer for this job. Jackie's going to kill me.
Yeah. So back in data pipelines, and then we can go Python-m Luigi -dash module example. So that's the name of the file, and then it's my task. And oh, I forgot to throw it. And you also need to throw this local scheduler flag. So there's actually a Luigi daemon, I'll explain this in a short bit, that lets you sort of schedule jobs on like a cluster or on your own machine. So the local scheduler is just built in. It's how you quickly hack and run code very fast. So run that, and you'll see checking if my task is so here I can grab this.
Can you turn your brightness up because I can't read it over your shoulder?
Yeah, there we go.
Thank you.
There are no more tasks to run at this time. There's a worker, so it handles like all this sort of effort of like distributing this unit of work, which, although this is kind of dumb to do if we're running it on my laptop, if you happen to have a cluster of machines, you can see why it might be useful to have something that will distribute work for you. So there's one scheduled task, and it has one dependency, which is itself, which is my task with param 42. And it didn't run because if we go look in my temp directory, here, I'll just one-hand it. It's easy. If we look in my temp directory, you'll see that there's already the foo folder and a bunch of different examples from when I ran this, when I was debugging this code this morning. But if we were to change it and we give it param and then what's somebody's favorite number that isn't 42? 8. So it's going to run. The task is successful. And what's interesting here is just for debugging is this actually ran this time. But you'll notice that for when we ran it the last time, that it didn't actually run because the target, which was foobar -42.txt, already existed. So it was like, this file already exists. I don't need to rerun this computational job. That, we barely wrote any lines of code, and we already got that like fairly tricky piece of ETL logic built into our system. So that's super useful. So what happens if, for example, we were to remove the entire temp foo folder? Well, try to actually spell it correctly first. And we ran it again with 8. Works again. It will create the folder. You can see this in bar 8 exists, and then we run it again. It's going to run. Progress looks good, but there's didn't run any tasks. So that's sort of the like, here's my neat trick. You're not going to be rerunning scripts that have already ran before because you've managed to turn everything into an atomic file operation. So that's our first little example task. So you might ask me, but Hunter, my ETL process is in a database, not in file systems. Like, this is not just for operating on Mountain. Out of the box, you get support for S3 targets, Postgres tables, HDFS files, BigQuery, and it's very easy to subclass target to produce your own custom target class and log. If you have your own like file system you need to operate on or database, so you can subclass target to sort of give it its own update logic to see if something exists or does not exist. You know, that's sort of the question target is asking. Does this exist or not exist? So, how do you run Luigi? There's a lot of different ways. So, the first option is what I showed you in, is you can run, it gives you command line Luigi. For those of you who use Conda to install Luigi, there's something wrong with the file path options it installs, so you have to prefix it with python-m. I don't know what it is, but it just is that way. So if you just prefix that thing, and notice that local scheduler flag. So you can start the Luigi daemon, which will give you this whole interface for visualizing your process and sort of what's happened. So I'm going to start the daemon and show you what that interface looks like, but for the purposes of this workshop, we are only going to rely on the local scheduler. Yeah.
I'll do mine.
So we can start Luigi, the daemon, by typing Luigi D. It's started up. I'll go back to the folder, and let's just nuke the entire food directory for now. And so I'm going to get rid of this local scheduler option. But first, I'm going to go to localhost 8082. And right now, it's got no pending tasks, no running tasks, no done tasks. But for those of you who work at larger companies with data teams that are larger than mine, you might have a whole group working on ETL steps, and this is very helpful to have a centralized server that can tell you how everybody's upstream tasks are doing and such. So, nothing right now. Send it off a job. Refresh. And look, it ran my task with parameter 8. Here's the time. There's a priority queue for when you have like lots of different tasks to run and a whole graph. But for now, there you go. You can send it off again. It's not going to run. And see, it's only done one task still because it said this already ran. We already had with parameter 8. Can send it with the default parameters. We'll get another task again, different timestamp. So that is the magic. Additionally, for those of you who are like me, I mostly just use like a script that had, so I always like writing like Python filename.py is how I run scripts. So if you add this little sentence inside, or you're running inside a Jupyter notebook and you're wondering, how do I run a Luigi job? You can add luigi.run and the task name and any sort of flags provided as a list, and it will let you run Luigi via the script that you wrote it in. So it's often useful to add that like little magic incantation at the end because it's always really hard to remember like Luigi-module, my module name, you know. This you can throw in your code and make it really easy. Just you can get back to the old Python filename.py. It runs, it works, it's super useful. You can also just use that inside a Jupyter notebook that you've defined a task in, and it will run inside the notebook. So that's also useful for those of you who use Jupyter notebooks for your development environment, because people are like, well, how do I do that? So the other question I get a lot about this is sometimes the interpreted state is not actually a text file or a database table. The interpreted state is often a data frame. You've taken a data frame, you ran value counts on it, and now you want to, so the nice thing is you just write pickle files to transfer them between there. So this is an example that is an external task that creates an empty data frame, writes it to a pickle file, and then outputs it as temp.df.pickle. So that's how you can pass data frames or scikit-learn models around. So that's useful. One like buyer beware with pickles is like only load pickles from trusted sources. So don't just have this generally be in like one pipeline. Don't be like pulling in pickle files from like S3 that you might not know. Like have this be created on one machine for security purposes. You can read more about this in the documentation for pickle. So this is the group hacking portion of the workshop. If you guys could form like 1 to 2 groups per table or so, I know there's a bunch of you in the back who can sort of create them up, and pick one person to sort of type, and you guys all code. I've got a situation. You are all now data analysts for the city of Washington, D.C., and the city of Washington, D.C. has been so kind to put up permits data on their website. So yeah, there's open data, and if you search permits, well, you'll see that the city has actually shared the building permits they've issued from 2012 through 2016 up on their website. And what I've given you is if you go to bit.ly/PyData DC-pipelines, you'll actually get this presentation in a very meta sense, a presentation that links upon itself, but you'll also get this example DC pipeline, which is a Luigi pipeline that has none of the code written. So I have some questions of this data that I have for you all to answer. Like, which word has seen the most development in the last 4 years? How can we combine these 4 different data sets into a single data set? So There's a years dictionary that will give you links to those CSVs so you don't have to go individually copy paste those. But I would recommend cloning that repo, and it's set so you can run, the first task is going to be the download task. And you'll see how each task depends on the task prior to it by looking for the definition of requires. And you can see that it's set to output in a data file. But here's some interesting questions. I'd love to see how y'all answer them. I will be coming around answering questions. If you can form like groups per table or per half table, depending on how crowded it is. I've found this exercise works better when you have like 2 to 3 people, 2 to 6 people like working on one machine rather than just one person by yourself. So let's get hacking. Let's figure out how open data tells us about our city. Yeah. And let me know if you cannot get Wi-Fi on at least one machine. I know there was issues in earlier workshops about that. All right, sweet. So we've got 15 more minutes, and I know not everybody made it through all the way because this is not designed to be finished within the time frame I gave you. So please do not worry about that. What I will do is up on that GitHub by the end of the day, once I finish squashing a few more bugs, will be like a nicely documented version of this you can refer to. The other thing I did want to demonstrate was that you don't have to just use files, because we were just playing around with files today. So I'm going to do that for about 5 minutes, and then I can do Q&A for the last 10, or you can continue hacking on stuff. So the other thing is, inside Luigi, there's a lot of barely, let's be honest, barely documented. This is like one of the flaws in the package is like, they don't tell you that they actually have like an entire insert to Postgres thing that's really easy. So this code actually, if you ran this, you, instead of inheriting from task, you inherit from copy to table, and then you just give it the column, you just override the column attributes. And if there's a CSV with those pairs that it's reading from, or a text file, that's going to insert that into Postgres, just copy to table. That's really quick with only a few lines of code. So that's really useful. It's also really useful. Don't know why my markdown did not render here, but this is all you need to do to get a query out of Postgres, or BigQuery it actually has similar syntax. So you just give it the columns dictionary, which you can actually generate programmatically, and then I gave it a query where it's like select star from table name where the artist is the postal service, and it can require any sort of other dependencies that create that table. So that's really useful. Also, you can step this up from simple batch processing on a local machine to batch processing on something like Spark. If you had a file named wordcount.py, this is how you'd submit a Spark job as part of your data pipeline, which is really easy. So you just give it configuration, and I'll demonstrate that in a sec, title of the driver, memory, and then just give it a name and a application file that reads in from that. There's an example of wordcount.py in the repo. And then Luigi also has lots of different configuration options, which is useful because you might want to say, do this on the development ETL server beforehand, and then the production ETL server. You can define Hadoop and Spark versions. So this is really useful to like stitch together data pipelines that operate on like different set sizes of data, which is like often your data goes from fairly big to fairly small fairly quickly. So if you have like stuff that needs to be done using Spark or Hadoop, but by step 3, you're already at the stage where you can throw it in memory in Python, and it's a lot easier to write your analysis in Python. This is one pipeline that can handle all of that. And you can use the configuration to sort of keep track of your secrets, like your database connections and such. So that's, here's a couple examples. The OpenE meter is this massive Python package that I developed at my old job that open source that sort of led me down this whole road of like insanity ETLs, which was there were 20 different energy utilities that are all submitting utility data that needs to be deduped on an hourly basis. And this is how I ended up here. Some links to the Spotify presentation. They're nice folks over there who will answer questions about that. Otherwise, Q&A for the last 10 minutes, or do people want to continue hacking on their projects? Yeah.
Is there an unusual way to force a task to rerun besides deleting its output?
So it's either like a parameter, like it needs to be run on any day, or delete the output. That's probably, yeah. And now the question was, for those of you who can hear, is like, is there a way to force a task to be rerun? It's to make sure that the target that is upstream of it doesn't exist, basically.
Do you,
Yeah.
do you do that through a remove generally, or do you generally touch the upstream targets to move their dates forward?
I would say generally, so the date, move the date forwards. If the date is like tomorrow, theoretically tomorrow's run shouldn't exist, so when you kick off the cron job, it will say, oh, we ran this model for the last 300 days, but not today, so we're only going to run today's parameter version.
So better to do the remove than to do a touch like you used to do in make world.
Yes, yes.
Thank you.
Last question back there? Or?
Do you have multiple dependencies?
Yeah, so in terms of like upstream dependencies, there's both you can provide requires is actually you can feed it returns different things. So if you have task A and task B, you can say requires task return task A comma task B, or you can also have examples like if you look in the merge datasets function where it requires clean CSV, but for every different parameter of the last couple of years. So there's two types of requirements that I like to think about with upstream was whether, okay, it requires step 1, or okay, it requires step 1A, step 1B, step 1C, because it is like a dependency graph. All right, thank you all so much for participating. I know this is like sort of hands-on and weird, so for a workshop, so love you all for playing along, and hopefully you all learned something, and you can find me on the internet and ask me questions.